Hey guys, in this lesson we're going to talk about dividing radicals and rationalizing the denominator, but we're only going to talk about higher roots. So I have another video where I talk about square roots. This one is, so working with higher roots, this is actually a bit trickier than square roots, so it really deserves its own video. Just as a reminder, pause the video and try the examples, and there are always free guided notes available. Okay, so the first thing I just want to make sure you know how to do is how to rationalize. So pause the video and hit play when you're ready. Just try these two examples to get you warmed up. So for this first one, so you just want to multiply the top and bottom by the square root of 3. So this would give me 5 times the square root of 3 over 3. And then for this other one, so notice I could actually simplify here. So I could divide, I could divide the top by 6 and the bottom by 6. So this will just actually simplify to 1 over the square root of 3. And then I can rationalize that to get the square root of 3 over 3. Okay, so this is something you should feel already pretty comfortable with before you start this video. If not, I would highly recommend just check out the comments and go check out the video on how to rationalize with square roots. Okay, so where I want to start here is we can't just use the same method from square roots to rationalize with higher roots. So let's pretend for a second that I did want to try that. So let me just show you what happens real quick. I'll actually do this in orange just to kind of make it clear that this is wrong. So I multiply by the cube root of 3 and the cube root of 3. Now you have to actually think about this when you're doing this. Don't just assume, oh, I multiplied the root by itself so it cancels out. You have to ground this in the actual mathematics, right? So the top is going to be 5 times the cube root of 3, and then the bottom, this becomes the cube root of 9. So can I actually evaluate the cube root of 9? I can't do anything with that, right? I can't simplify this any farther. So this method kind of illuminates, or trying to do this, illuminates that this is a totally different thing. And it's a little bit harder to rationalize. So where I want to start is getting you used to thinking about what is it that you actually need to multiply by, because we're still actually going to use the same idea, we just have to tweak it a little bit for higher roots. So I'm going to have this kind of unusual exercise that we're going to do, but I think this will really drive home kind of the point here. So my question is, if I have the cube root of 3, what do I have to multiply that by so that I end up getting just 3? Well, we know that it's not the cube root of 9, right? Or it's not the cube root of 3. We already looked at that, right? It's not the cube root of 3 because the cube root of 3 times the cube root of 3 will equal the cube root of 9. That will not get me to actually 3, right? So now you just have to think about which cube root will actually get you to 3. Well, the cube root of 27. So what I need to have happen here is actually for this to give me the cube root of 27. So notice that the cube root of 3 times the cube root of 9, this gives me the cube root of 27, and the cube root of 27 is 3. So here's kind of what you're thinking about. But I want to think about this now on a slightly different level. So instead of thinking of this as just straight up numbers, I now want to think about powers here. So the cube root of 3, so how many powers of 3 is this? I know that seems like a weird question, but this is just one power. So I'm actually going to just note that here. I know we normally don't write that, but just go with me here for a moment. Now, for the cube root of 9, if I wanted to write this as, instead of in its exponent form, this would be 3 squared. So notice what we have here. I have 1, I have 2. So what is 1 plus 2? Well, it's 3. And notice that's what our actual index is, right? There's my index. So here's kind of what you're trying to do. And when I multiply these together, so think about what is actually the cube root of 27. The cube root of 27 is 3 cubed. Once you get this exponent here to match its index, this is actually what will allow you to kind of cross those out, right? And then you end up with 3. So we've seen this before as we've kind of been studying this. This is actually the idea that we want to try. So I'm going to give you a bunch of exercises where we just kind of focus on this, And I don't actually care so much about the numbers here. I really want you to think about this in terms of powers. So let's do a couple more together. So right now I'm telling you what I want the target to be. And so here I'm giving you the cube root of 25, and I want to know what do I have to multiply that by to get to 5. The first thing I want you to do with this is I want you to, anytime you can, rewrite those numbers in their exponential form. What you're trying to do here is you're trying to think about the number of powers of a particular number that you need to match the index. So now I can see that I have 2 powers of 5. How many more powers of 5 do I need to get to 3? I just need 1 more power of 5. So once again, I have this 2 plus 1, so that will equal 3. So if I multiply these together, I get the cube root of 5 cubed. That is 125, but you don't have to think about it like that. I think right now it's much better if we just think about this in terms of powers, and then this will equal 5. Okay, so let's do one more together. So now I've got the 4th root of 2 times what will equal 2. So I need to multiply this by a 4th root. So I have 1 power of 2 in this case. How many powers am I actually looking for in this example? I'm looking for 4. It's all driven by the index. So if I have 1 power, how many more do I need? I need 3 more. So this will be 2 to the 3rd. So if I multiply these together, I get the 4th root of 2 to the 4th, and then that will equal 2. So here's kind of the whole idea behind this. And so I always think about it as counting powers. So why don't you try these two, again, rewrite them in their exponential form, that will be a big help, and hit play when you're ready. So for this first one, I want to rewrite this as the 4th root of 3 cubed. Sorry, that's a terrible 3. 3 cubed. And I have to figure out, what do I want to multiply this by? So once again, I have now 3 powers of 3, and in this example, I need 4 in total. So I need 1 more power of 3. And so then here's what this will look like, and that will get me to 3. Okay. Now for this next one, once again, I'm going to rewrite this. I'm going to write this as 2 squared. And so now I have 2 powers of 2. I need to get to 5 in total. So how many more do I need? I need 3 more. So I need to multiply this by 2 to the 3rd, and kind of what's happening in the background. This is going to become 2 to the 5th, and then this will ultimately equal 2. All right. So hopefully you've got this idea, but I want you to try this 4 more times. So I really want you to get this. Hit play when you're ready. Okay, for this next one, I only have 1 power of 7. So I need to multiply, I need 2 more powers of 7 in this case. So here's what I need to multiply by. That will get me to, here's 1 power, here's 2 more. That will get me to the 3 powers of 7 that I need. That'll get me here. Okay, so now for the next one, I need to rewrite 25 as 5 squared. So then I have 2 powers of 5. How many more powers do I need? I need 2 more to get to 4. So that will ultimately get me to 5. All right, so for G here, I have 1 power of 3, but I need 4 in total. So I need to multiply this by the 5th root of 3 to the 4th, and then that will give me 4 plus 1 power of 3. That's 5, the total that I need, so that will break the 3 out. And now for this last one, so if I rewrite this, so 36 is really 6 squared, so I just need 1 more power of 6, and that will get me back to 6. So I realize this is kind of a strange exercise, but you'll totally see where this is going in a second. So I'm going to bring all of this together in a moment. So now what I want to do is I want to just switch this slightly so that I kind of get you used to what are you trying to get to here. So notice in this exercise, I don't tell you what I want this to equal. You have to know what this is actually going to equal, which you kind of should by this point by looking at the pattern. So What I want you to do now is you can always figure out kind of what your target is that you're trying to multiply by if you rewrite these numbers in their power form. So what I mean is 4 we know is 2 squared. So what this means is this is the number then that you are trying to get to. You want this to actually equal 2 when you're done. So that's kind of the way that this is going to work. So then I have to multiply this just by the square root of 2, and then this will ultimately equal 2. So I want you to just kind of now finish out the whole pattern. You will totally see where this is going in like 3 more minutes. Just go with me here for a second. So with the 4th root of 5, so in this case I can't rewrite 5 any other way. So I have just 1 power of 5. I want to figure out what do I have to multiply this by to get me back to 5. So in this case I have to multiply this by 3 more powers of 5, and then this will ultimately get me to 5. So I want you to just complete this pattern here with the next 2. Hit play when you're ready. So for C here, this is really the 5th root of 3 squared. So 3 is what I'm trying to get to here. So I have to multiply this then by the 5th root of 3 cubed. So I need 3 more powers of 3, and that will ultimately equal 3. Now for this last one. So I've got the 4th root of 36. So again, I write that as 6 squared. I see that I've got 2 powers of 6. That means I need 2 more powers of 6, and then that will ultimately get me back to 6. So this is kind of your goal here, is to always think of these things in their exponential form. Okay, so now let's actually talk about rationalization. So this is actually exactly what you have to do to rationalize, except you just have to multiply by the bottom and the top by the same thing. So in this case, when I look at the cube root of 2, so what do I need to multiply this by to ultimately get back to 2? Well, I have 1 power of 2, and I can see that I need 3 in total. So I need to multiply this by the cube root of 2 squared. Whatever I do to the bottom now, I have to do to the top. So if I multiply this together, here's what this looks like. 5 times the cube root of 2 squared over the cube root of 2 cubed. So ultimately this will equal, so now we want to simplify everything. This will be 5 times the cube root of 4, all of that over 2. So my goal for you would be for you just to jump maybe from this step to the last one, but you might need to work out all of these details a few times and actually like think through this. So don't just be like a computer, like up this. Actually kind of reason your way through this, and then this will make this more approachable for you. So for this one, so now I want to get the denominator to ultimately equal 5. So it's really helpful if you kind of know what you're shooting for here. So I have 1 power of 5, I need 3 more powers. So I'm going to multiply the bottom by the 4th root of 5 cubed. Whatever I do to the bottom, I have to do to the top. So let's work this all out then. So I'm going to show you all these details one more time. So this is going to give me 7 times the 4th root of 5 cubed. And then in the bottom, I've got the 4th root of 5 to the 4th. So after you do this, so you know that you needed to have 5. That was what you were kind of shooting for to have in the bottom. But you do want to actually evaluate this number in the top now. So for completeness at the very end, then you want to go through and simplify everything. So think of it like this, and then you want to make your answer look nice and complete, and so this would be fully completed. So you will find when you are working with radicals, it's not uncommon that you kind of have to think back and forth between their exponential form and then like their full number form, and it just depends on what you're working on. Okay, so I have a couple more of these for you to try. Hit play when you're ready. Okay, so for this one, so I already have 1 power of 5, so I need 2 more powers of 5. So I'm going to multiply both of these by those 2 more powers of 5. So this will give me 6 times the cube root of 5 squared, and then this will be the cube root of 5 cubed. And so ultimately this is 6 times the cube root of 25 over 5. Okay, so now for this next one. So the first thing I want to do here actually is I want to rewrite this one. So we're going to think of this as 2 over the 4th root of 3 squared. That will just help me to think through the powers. So if you need to actually go ahead and write this out. And now I can see that I need 2 more powers of 3. And so if I multiply these together, so now if I just want to kind of jump ahead here, so what was my goal? My goal was to actually turn the denominator into a 3. So I know that this is going to give me a 3. And then I've got 2, and then the 4th root of 3 squared. 3 squared is just 9. So here's what the answer actually looks like. So I'm going to just kind of jump forward to these now. All right. So I have 2 more for you to try. Hit play when you're ready. So doing the same thing again. So now I've got 2 over, this is going to be, oops, not the cube root. This is going to be 2 over the 5th root of, so what is 125? 125 is 5 cubed. So that means I have 3 powers of 5, and so I need 2 more powers of 5. So this is going to be times the 5th root of 5 squared. Okay, so what was I going for here? What did I want my denominator to ultimately be? Well, I wanted it to be a 5. So I'm not even going to multiply these together. I just know that this is going to work out now because I have enough powers of 5, because 3 plus 2 equals the index of 5. Now for the top, this is going to be 2 times the 5th root of, what is 5 squared? It is 25. So there's my answer there. Okay, so one more here. So now I've got 7 over the 4th root of, this will be 2 cubed, so rewrite 8 as 2 cubed. So I have 3 powers of 2. I can see that I need 1 more power of 2. So I'm going to multiply the top and bottom just by the 4th root of 2. And ultimately this will get me 7 times the 4th root of 2 over 2. All right, so I have even more examples if you'd like to see them. Otherwise, I mean, this is all the video is going to be from here on out. So if you want to practice more, just stay tuned. Otherwise, if you're done, please consider commenting, and subscribing to this channel. But otherwise, if you feel that you need more practice, pause the video and hit play when you're ready, and I'll go through some more of these with you. So here, this is the same idea, right? So I've got the cube root of 5, and I have to write this not as 4, but as 2 squared. And now I can see that I have to multiply the top and bottom both by the cube root of 2. And so in this case, this is a little bit of a plot twist in some ways, because now I can actually multiply these 2 numbers on top together. So 5 times 2 is 10. And then in the bottom, this will be just 2. So it's cube root of 10 over 2. Okay, so moving on to B here. So this is 2 times the cube root of 3, and I want to rewrite the denominator not as 4 but as 2 squared. So what do I need in this case to multiply the denominator by? Well, I have 2 powers of 2, so I need 1 more power of 2. So here's what I'm going to multiply by. Okay, so I've still got this 2 on top. I can multiply the 3 and the 2 together to get 6, and then what should my denominator become? So the whole point of this was to make this ultimately equal 2. And now you will notice here, I can actually simplify this farther. So these 2's will drop out, and I'm just actually left with the cube root of 6. So that's it for that one. Okay, moving on to C here. So now I've got the 5th root of 4, the 5th root of the 4th root of, I cannot speak, 5 times the 4th root of 2. And then I'll rewrite the denominator as the 4th root of 3 cubed. So I can see in this case, I just need 1 more power of 3. So ultimately I get 5 times the 4th root of 6, all of this over 3. And this one you can't simplify any farther. Okay, so if you want even more, so I have just 3 more here, so you can hit play when you're ready if you're looking to practice even more. Okay, so for this one, so I've only got one power of 3, so I need to multiply the top and bottom by 2 more powers of 3. Okay, so now when I do this, so this is going to be 3 on the bottom, and then this is 6 times the cube root of, and now you have to kind of keep this straight. So this is 5 times, what is 3 squared? 3 squared is 9, so this is really 5 times 9. 5 times 9 is 45. And you'll notice here you can actually simplify this, so this becomes 2 times the cube root of 45 because 3 divides into 6 twice. Okay, so for e here, I have this just in the nice variable form. So I can see I have just 2 powers of x. So I have 3 powers of x, and I'm going to need 2 more powers of x. So I'll multiply both the top and bottom by the 5th root of x squared. And so this becomes 3 times the 5th root of x squared, all of this over x. Okay, so now for the last one. So I don't need to rewrite the top as 5 squared. I can just leave this as 25. Really, rewriting out these powers is just something that we do so that we can figure out what we need to multiply by for the bottom. So you could think of this as in 2 ways. You could think of this as 4 squared, or you could think of this as 2 to the 4th. It's going to be less work if you think of this as 2 to the 4th, because then you just need 1 more power, and also it's going to just make multiplying the top a lot easier. So I would choose, like, try to max out the number of powers you can have if you do have a choice. So in this case, I already have 4 powers of 2. I need 5 in total, so I just need 1 more. So ultimately, I get the 5th root of 50 then over 2. And so those are all the examples that I have for you. So please consider liking, commenting, and subscribing to this channel. And I do have some more videos on rationalizing. There are some other types to discuss, but that will cover it for higher roots. So I'll see you guys next time.